So this is going to be the DI-124. I have to apologize if you hear a squeaking sound. It's because someone is using a pressure system to hose off the pavement, and I think it's just the pipes as the pressure builds up and releases. So it's kind of funny, but like I said, I apologize. So it says determine if the following are symmetric over the x, y axis, and origin. So to determine if it's symmetric over the x-axis, what we're going to do is we substitute y for negative y, and we look and see, is it the same as the original? So I plug in negative y in for y, and if I compare this to the original, no, they're not the same, so no, it's not symmetric over the x-axis. So now let's see if it's symmetric over the y-axis. You plug in a negative in for x. So we get y equals negative x cubed minus negative x. Now, again, remember we have to pretend like there's parentheses where the x is, and we're replacing those what's inside the parentheses with negative x. Negative times a negative times a negative. Negative is a positive. Is that the same as the original? No, so it's not symmetric over the y-axis. Now we want to see if it's symmetric over the origin. So we plug in a negative for both. So negative y, does that equal, and I'm just going to use this statement here. Now at first we might look at this and say, oh yeah, no, there's no way that this is symmetric. But what if I factor out a negative? Well, if I divide both sides by a negative, now that is the original. So yes, it is symmetric over the origin. So moving on, determine if the following are symmetric. So negative y, is that the same as, so this is over the x-axis. The answer is no, those are not the same. There's nothing I can do to manipulate it. Is it symmetric over the y? So we plug in a negative for x, so y equals negative x squared plus 1. That turns into positive x squared plus 1. Yes, these are the same, so it will be symmetric over the y. Let's see about the origin. If I plug in a negative for both, those are not the same, so it's not symmetric over the origin. So it's only symmetric over the y-axis. Let's do the same thing for number 2. So symmetric over the x, plug in a negative for y. Not the same. See if it's symmetric over the y. Man, this little squeaky noise is really annoying. Those are not the same, so it's not symmetric over the y. See if it's symmetric over the origin. Plug in a negative for both the x and the y. Those are not the same. You can't pull out a negative or do anything like that with a square root. So it's also not symmetric, so neither. For the next one, so I'm going to determine if it's symmetric over the y. So I'm plugging in a negative for the x. Those are not the same. There's no way I can simplify that negative or anything like that. So it's not symmetric over the y. Let's see if it's symmetric over the x. So I'm going to plug in a negative for the y. Okay, well that becomes plus y squared. That's the same. That's the same. So it will be the same. So yes, there's symmetry over the x. Now, immediately, because if I do both, I'm going to get this, and there's no way for me to simplify it. It's not going to be symmetric over the origin. So on this next one, let's do symmetry over the y. I don't know why I switched the order of which one I'm doing. It doesn't matter really which one you do first. So we're plugging in a negative for the x. So negative 3x minus y equals 7. Those are not the same. So no symmetry over the y. Let's see if it's symmetric over the x. That becomes plus y. Those are not symmetric. So not symmetric over the x. Now let's see the origin. We plug in a negative for both. Now, let's see. So is it going to be the same if I factor out a negative? Equals 7, sorry. Okay, there's nothing I can do with that negative, so it's not symmetric about the origin. So, neither. So for this one, let's see if it's symmetric about the x-axis. So let's plug in a negative for my y. Negative is a positive. So, yep. So it is symmetric over the x-axis since it's the original. Let's see if it's symmetric about the y. So I plug in a negative for x. Yep. And if you plug in both, you're going to find out that it's symmetric as well. So describe the given relation using either the roster method or the set builder method. So let's define our x and y, and let's see what's going on here. So it seems like my x starts at 0 and goes up forever. So I'm going to say x is greater than or equal to 0. And my y, oh sorry, that would be my y, but my x, yeah, same thing. It starts at 0 and goes on forever. So both of them are going to be greater than or equal to 0. And it's a solid line, so that's why I'm going to say equal to on both of these. For my relation here, so setting it up, I have my x and my y. For my x, it seems to start here at 3 and go on forever. So I'm going to say x is greater than or equal to 3. Now my y value is only at 3. So I can actually change my y to just say 3. That's my answer. For the distance formula, remember that the distance formula is the square root of the two x values squared, and you add it to the two y values squared. And then the midpoint formula is you add them together, divide by 2, add them together, divide by 2. And you create a new point. So let's look at number 9. So the distance of x minus 0 squared plus y minus 0 squared. So the distance equals the square root of x squared plus y squared. And that's my answer. The midpoint, I know you may think, oh, the square root and the squares cancel out. They do not cancel out. We'll find out more why later in this class, but I know that we think that we want to cancel them out. You cannot cancel them out. So add them together, divide by 2, add them together, divide by 2. So the midpoint is going to be x over 2, y over 2. Because on separate sets of axes, make a complete graph of each of the following functions. So for A, for example, you want to create a table and you want to plug in points. So if I plugged in 0, 0 plus 7. If I plugged in 1, negative 1 times, or 1 times negative 2 is negative 2. Negative 2 plus 7 is 5. If I plugged in 2, negative 4 plus 7 is 3. So that means I can graph that. Yeah, that should be enough. Oops, should be a little lower. But that should be enough for me to determine that this is a line. So I can go ahead and sketch it. So you're going to go through and you're going to do that for, to give you a hint, C is also a line, B is also a line, and D, if I plug in 0, I get 0. If I plug in 1, you get 1. If I plug in 2, 2 squared is 4. Okay, that's not a line anymore, right? So we should, if I go through and I plot these, we should realize, oh wait, maybe I don't have enough information because this is not a line anymore. So maybe start plugging in negative numbers. So if I plug in negative 1 squared is 1. If you plug in negative 2 squared is 4. So it's actually a parabola.